Today we will learn about translating graphs, and for this we will work on quadratic graphs. By learning the transformation of quadratic graphs, we would be able to apply that knowledge to any other type of graphs. So let's start our today's lesson. So, for example, we do have a function, and this function is f of x. And for a quadratic graph, let's say in a very simple way, it is just x square. So this function means that we have a function which depends on a parameter x or a variable x. So it means this x is independent along the x-axis and f of x is dependent, which is along the y-axis. So we can write it as y is equal to x square. So this graph, how would it look like? Because it is a quadratic, so it will be simply a parabola. And let's see, we have here that y is equal to x square, and then we have a simple parabola. Now we apply first transformation, and that transformation is that we are going to add in independent variable, meaning that now our function will be f of x plus some number a. So this means that we are going to replace our x with x plus a. So our new function will be x plus a square. Now this one actually got a transformation, and this transformation is along a vector, and that vector you can see that it is along the x-axis and y-axis we are not changing. So along a0, that will be the transformation. What does this mean? Let's see here that we have our another function, which is y is equal to x plus 10, it's a square. So what happened that this our red parabola, it has shifted towards the negative x-axis by 10. Now you see our vector 10 along the x-axis and 0 is along the y-axis. When we are adding in x parameter, then we will actually have the shift towards the negative x-axis. So this means that when we do have here addition, then our vector is actually negative a0. Now let's check that if, for example, we take away, then what would happen? For example, if we have a y is equal to x minus 10 square, now our actually parabola has shifted towards the positive x-axis, and this transformation is actually along a vector positive a and 0. So now the first transformation is addition or subtraction in an independent variable, which is the x. If we are going to add, then our parabola is shifting towards the negative x-axis, meaning our actually the transformation vector is negative a0. And if we are taking away, then it will be positive a0. This is the vector of transformation, meaning our parabola have shifted towards the positive x-axis. Now we actually go to have multiplication, meaning that we are going to multiply our independent variable. What would happen? So let's switch off these two parabolas and we go back to our first parabola, which is f of x is equal to x square. Now, if, for example, I times a number with our independent variable, and this is actually our new function f of ax. So in this case, what will happen that our function or this parabola would squeeze or it will stretch. And this actually depends on the value of a. If a is greater than 1, then it means that we are squeezing our parabola. In other words, you can say that you are going to multiply your independent variable with a number which is greater than 1, you are actually squeezing x-axis. But now, if, for example, our a value is less than 1, then what will happen? That it will stretch. So now our actually parabola has been stretched because our a is smaller than 1. So this is a second type of transformation. Now, the third transformation that we can understand by adding or subtracting in the function. In the function. What does that mean? This means that if, for example, I have this function f of x is equal to x square, and I am going to add or subtract a number into this function. So this was our original function. Now this is our translated function. So now what will happen? Let's have a look. So here actually the function, it will actually follow this addition along the y-axis with the sign. For example, if I have x square plus 5, so it has shifted along positive y-axis. And if I have y is equal to x square negative 5, then it has actually shifted along the negative y-axis. So for this, we can also actually write the vector of transformation, and this vector you can see is 0a. So this time we do not have a negative a as we have in case of independent variable x. For actually addition, it was negative a0. Now, for actually this one where we actually take away, then our vector will be 0, negative a. Now, with our first transformation that we studied, that addition or subtraction in independent variable, and we combine it with the addition or subtraction in the y parameter, what would happen? So you can very easily see that, for example, if I combine both of them, then what will happen? That our vector, this time we have addition in independent variable, and we also have the addition in actually our dependent variable, which is actually the y-axis, meaning this is an addition in the function. So from this, you can very easily understand the vector of transformation. It is negative 10 because it is addition in independent variable, and positive 5. So now our vector, you can see negative 10, positive 5. So our vector of translation is over here. That is actually negative 10 I. I means it is actually along the x-axis, then plus 5j. J means it is along the y-axis. So this is actually our vector of translation. So here, this is actually the simple way of understanding the translation of different graphs. So what we can do here, we can actually also try a different other transformations. For an example, that what we do now, if, for example, we change the sign, what will happen here? Now, if we have y is equal to x square and we put a negative sign, then it will flip. And with this addition, if we have a negative sign, then we will have actually, you can say, is negative because addition towards a negative, and then this negative is actually just flipping. So the negative sign in the parabola is just shifting, meaning that you are just giving the negative sign to your function to go towards the negative axis. So these are very simple rules of transformation. and you can actually you should try to understand the vector of translation. Now, with this understanding, you can also try different other graphs. Let's try only one more. For example, we have a trigonometric graph. For example, we have y is equal to sin x, and here x is in radians. So I increase its amplitude by actually multiplying it with a number greater than 1. Let's say it is 10. Now, what you can do, you can actually see that what would happen if I have addition in this function, and that addition is, let's say, 90 degrees, meaning pi by 2. This is a pi by 2. Now, if you see carefully here, that what happened, that what is going on, that our actually this sin graph, we have addition of 90 degrees shifted towards negative x-axis by 90 degrees. Now, if we see now our this peak value is at x is equal to 0. So what happened? Now our sin graph has actually changed into cosine graph. So this also tells us that the sin and cos, they are very close cousins with 90-degree phase shift. So this actually, the transformation you can apply to any other types of the graphs. Now I believe that if you understood this, you can also try cubic graphs or inverse reciprocal graphs and other trigonometric graphs, and try to translate them along different vectors. And here, this is I'm doing this all on Desmos. This is a very interesting and very nice platform for learning. So you can try, you can use it, and you can learn the different types of translations in your vectors. Hope you understood it. If you do have any question, just leave your question in the comment section, and we will try to reply to your all the questions and queries. And also do not forget to support your channel. Thank you very much for listening.